Now we will fill the soil.
Yeah, we will fill the soil.
At what
Say, for an example, up to this total height is of 340, up to 200
centimeters.
200 mm, 20 centimeters.
20 okay.
20 centimeters first to fill the soil. So before filling the soil, you must understand the component and the
Yeah, please let me know.
These are the piezometers. These all piezometers are connected to
Here, this piezometer, what do you use?
these are just called as silencers.
This you can make it there, right? It will be easy. No, this type of holes are there, no? Like a screen only, right? Then that problem will be solved. No?
No, I can go. This is called as cruciform pattern.
Okay.
Means it is covering this part also and this part also. These are total 19 members. And these are the what we call this as French drain. This is called as a French type of drain.
Okay.
So if you go back, this one, the water will come from here, and with the help of that wall, in front there is a one wall, it will go into this direction. So similarly, there is one, and with the help of that wall, it will go into this.
So simultaneously we have to fill it.
Okay. With the help of this control wall, we can control the water coming into this system. These are the control wall that is connected to this. Okay. Now there are in experiment. In first experiment, this will be considered as an inlet, and this will considered as the outlet. Water will come from here and will go from here. In that case, these two wells are not to be used, so we will close it.
Oh, it will be like a groundwater flow.
So it will be like a groundwater flow. So first experiment, we will do this it with a sand of 200. Then we will give some chloride. Since it is a groundwater storage, you need not to give
Too much
of chloride. Just a chloride so that water does not jump out of the.
Okay. Right.
Okay. You have to make it completely open. At one time, the water will start coming out of there. Before that, what you have to do is you have to close this. Water will rise, and water will rise, you will see from here.
Yes.
In case if it is air, it will be in air, you have to turn it like that. So that water comes out of there. When we see, okay, regularly water is coming out of there, make it again, make some taps. Still you feel there is some water, or in this you can see that no, water is not rising as equal to that. Simply close it, drain it, and you will, when you see that regularly water is coming out of there, fix it again. So suppose your sand is filled up to 200 mm. So we will wait up to 100 or 120 mm.
Okay. Fine. We will saturate up to 120 ml. Let's say for example.
See the water level. Okay. Then we will saturate up to say 180
80
or close to 200 mm.
Water fully saturated.
Water is saturated.
Then we have to close this or
this will be open. Still open. So the water is coming out. I will open this. Now the water will drain out of there. Then what we have to do is we have to maintain the first equilibrium. What is the water is coming? The same water should be going down. Its speed should not be greater than this. Then how will you going to find out it? You will see any one of the manometer. Suppose say you are seeing only this manometer. So you will start closing it. When you start closing it, you will see it starts rising. Then you slowly open this, it starts falling. At one place, you will find that it's neither decreasing, neither increasing. It is stable at the same place.
It will be
Anyone,
common for everywhere.
Yeah, it will be everywhere. So you have to just focus on one or two. Okay. So if it is not rising, so these all will be, you see, will be steady. Then you have to wait. You have to wait. After that, you will find it depends on the permeability of that soil, that gradient shape. What is the potential here? It will be at the highest potential, it will be at the lowest potential. But what is the difference between these two potential? That depends upon your permeability. If it is clay, if suppose clay which has the least permeability or almost no permeability, you will see it will be like that, straight. If you are using gravels or the sand, you will see it will be like that. You cannot maintain to a layer. It will rise very deeply. So you have to note down these distances are given in the manuals.
Okay.
What is the distance between these two points?
This one is performing. So we can.
And last time I made it. You can easily determine it. However, I have made. You will find a image of like that. The numbering will be given. The distances between each one is given. So you have the area. How much sand is the depth? You have the distances. You have the flow rate. Flow rate you can manually calculate. So you can find out by using Darcy's law, the permeability. Okay, so in this way you can find out the gradient. You can find out the permeability.
You mean to say that QIA, na?
Yes.
K is the conductivity.
K is the conductivity.
I is the gradient.
Gradient.
Left side will be the discharge.
Discharge you can find out from there.
Area is nothing but the cross-sectional area.
Cross-sectional area.
Which will be length into depth or width into depth, right? Cross-sectional area will be?
Cross-section area will be this. Length into the breadth. Area. Cross-sectional area.
So interior area.
Yes.
So this length and
Breadth
width
we have filled the same.
Okay.
Okay. Or should I open